Hello and welcome to Python in Containers course. Docker and Kubernetes are the must-have skills for Python engineers these days. Whether your goal is to learn Python for machine learning, data science, or to build cloud-native microservices, you inevitably end deploying your work in containers. Docker and Kubernetes skills are a key to become a respected and highly paid DevOps expert. In this course, you are going to learn using containers to package, deliver, and execute Python applications. It is very practical and has a lot of exercises. I think that examples and exercises are most productive way of learning. I strongly advise you to get hold of a laptop or desktop computer with Linux, macOS, or Windows. Not only listen and watch the lectures, but first of all, to do exercises. In Python in Containers, you learn to install and set up a development and execution environment to run your Python code in containers. Then, you're going to learn how to build container images with your Python code, how to ship them to other people, and how to run them. Finally, the course teaches how to run data science and machine learning tasks in containers. My goal is to make learning experience effective and affordable. I use open source or otherwise free software in this course. You're going to learn how to run your Python projects in containers on a development host, a laptop or desktop computer, but also in a production-like environment on a public cloud. Let's look at the agenda now. The course can be consumed in many ways. For example, if your primary interest is in machine learning and data science, you can start with Section 1 to get a general overview of Docker and containers, then take Section 7 to get quick practical overview of how to run daily tasks in containers. Use remaining Sections 2 to 6 to deep dive into specific topics related to Docker and Kubernetes. First section delivers an introduction to containers. If you have never learned about containers or worked with them, you're going to get a necessary introduction to key concepts here. We're going to define containers. The cycle of build, ship, and run gets introduced and explained. We do an initial introduction to Docker and other container tools to get an overview of what is available for developers. This section is more of watching and listening than doing practical exercises. All further sections are very hands-on. I strongly encourage you to spend an hour or so to watch all of Section 1 lectures. It is building a basis of concepts and terms which we are going to use throughout the rest of the course. At the end of Section 1, you see how to containerize a simple Flask-based Python application. Once the container image is built, we ship it to Docker Hub image registry and then execute it locally using Kubernetes. The same container image with Python application is then executed in a public cloud. Section 2 of the course gives you a Docker deep dive. We started with a series of lectures about installing Docker in various operating systems. We focus on free version of Docker software called Docker Community Edition. You're going to learn how to install a container development platform on Ubuntu and CentOS Linux. We also learn how to set up Docker on Windows 10 Pro, which comes along with built-in virtualization named Hyper-V. If you don't have the Pro version, we also cover installation of Docker Toolbox on Windows Home. For macOS users, we have a lecture on setting up a decent Docker development environment as well. Once a Docker environment is up and running, we talk about how to work with Docker tools. We start with the images, then discuss how to run containers and manage them. Section 2 introduces container networking and storage and their implementation in Docker. Dockerfile Introduction lecture presents the automation of container image building. Next, we introduce the concept of image registry and use Docker Hub as an example. Then we have lectures about Python images, graphical user interfaces to manage Docker containers, and Docker machine. After this comprehensive Docker introduction, Section 3 teaches the core skill of building container images. We start the section with overview of key elements of containerized Python application, its lifecycle, and design principle. Then we have an important lecture showing manual container image build process. I show it on purpose so you understand better what is a container image and how it is created. Then we have a series of 14 lectures showing how to build images in an automated, repeatable, and fully controllable manner by using Dockerfile. Last part of Section 3 takes Django as an example Python application framework and discusses various aspects of network server applications. We talk about implementing production-grade database engine using application servers to run Flask or Django or similar, and how to build a bulletproof front-end with proxy server. By end of Section 3, you will be able to design, build, and run complex multi-container Python application deployments. Section 4 focuses on delivering container images to the world or to operations team in your company. This way or another, it is about shipping container images with Python applications. We discuss the concept of image registry and learn how to use public registry of Docker Hub. Other image registries are also introduced and discussed in detail, for example, GitLab. This section also talks about automated image build pipelines, giving you a good introduction to continuous delivery. There is a lecture about image vulnerability scanning as well. Section 5 discusses running container images in Docker runtime environment. It starts with automation of multi-container deployments with Docker Compose. Then we discuss Docker Compose file format and how to use it. Docker Swarm is a container orchestration engine technology which enables us to run complex multi-container applications on clusters of Docker engine hosts. We discuss this technology in detail, so you're going to get good grasp of what it takes to run your Python application in production. Section 6 focuses on running containers in Kubernetes. This is currently the most popular container orchestration engine. My goal for this section is to give you, developer, deep understanding of how your Python application is supposed to run in Kubernetes environment. We talk a lot about declarative management approach and do plenty of exercises involving writing Kubernetes object template files. This way, you're going to learn how to describe your application deployment using Kubernetes YAML files. Section 7 shows practical application of Docker and Kubernetes to typical machine learning and data science tasks. We start the section with general discussion of using cloud-native tools in these areas. First practical skill you learn there is running Jupyter notebooks in Docker containers. You get detailed overview of how to create data science, research and experimentation environment with Jupyter, Anaconda, IPython, NumPy, SciPy, Pandas, Matplotlib, and the rest of the family in a Docker container in about 5 minutes. All you need is plain Windows, macOS, or Linux machine. For machine learning engineers, there are several examples of using TensorFlow containers for development and exploration of models. You also learn how to package a trained model into TensorFlow serving container image and run it as microservice in production environment. The section also has a lecture on running Docker with NVIDIA GPU acceleration. The course is going to teach you practical skills necessary to design and deploy your Python projects in cloud-native way. I'm so excited to get you on this journey to containers and clouds. Let's get it rolling with introduction of containers and key concepts related to them.